of ICOLD for his presence here. I'm Lara Carimo, Mozambique civil engineer specialized in hydraulic engineering and river basin development. I work for a company specialized in the fields of water and energy. Mid Atlântico has a specialist in hydraulics. I'm also a member of the Mozambican Dam Commission, and I will be moderating the webinar today. Before we start, just a few remarks. I would like to ask everyone to turn the microphones off and to please not open the links shared in the chats that were not shared by the organizers. The session is being recorded and will be available on YouTube via link shared in the ICOLD YEF LinkedIn group. Okay, moving on to the program. The program is shared here in the screen. First, we will have a welcome note from Mr. Michael Rogers. Then Janice Zhang will share a message from SANCOLD, followed by Valentina Favero, the coordinator of SwissCOD, that will also share some words. We will have a general information from the chair of ICOLD YEF, Elias Baptista. And finally, the presentation from Mr. Eliott Odermatt from Gruner Stucky SA. Later, we will open the space for questions, and the webinar will be closed by Professor Bose, president of the SwissCOD. We are now waiting for everyone to enter the webinar, and we will start in a few minutes with the welcome note from Mr. Michael Rogers. In the meanwhile, please share your names and the institutions you are affiliated with. We would like to know who is joining us today for this webinar.
Lara, I'm going to start sharing my screen. Is that okay?
Yes, that's perfect. Okay. I think that following with the plan, we can start now with Mr. Michael Bors, the president of ICOLD, to open the session.
Hello, everyone. It's great to be here. Thank you very much for joining this webinar. Special thanks to the ICOLD Young Engineers Forum, Chairman Elias Baptista, for inviting me to be here with you today. It's a great honor for me to be here, and as I always enjoy speaking with our young engineers in ICOLD, and especially when there are great forums like this. Also thanks to the Mozambique, Swiss, and South African national committees, and especially their Young Engineers group, the Young Professionals group, for their sponsorship of this webinar, and Mr. Eliott Odermatt for his offer of time to make this presentation. So thank you all very much. The Young Engineers Forum and these type of webinars are very important to ICOLD. ICOLD is all about sharing technical knowledge, and a big part of that is sharing that with our young engineers. So as we move forward today and tomorrow, there are some important things that for dams and reservoirs that ICOLD brings, and it's more important, I think, than ever that ICOLD be part of the conversations around dams and reservoirs, and especially as we come out of this time of pandemic and other stresses in the world. There's continues to be an increasing demand for critical infrastructure. That is, the water and the power and the flood control. We know that growing populations and the technology, and especially in developing countries, is pushing our countries to develop dams and reservoirs so to meet these demands. And there's that need for water and reliable power that these dams and these reservoirs and hydropower solves. And we are looking at both new and old aspects of what we do. And we as engineers and scientists, we are confronted with the new developments, but we're also dealing with the old projects. Many new projects that are continuing to be developed around the world, especially in areas like China and Africa, that where there's very large demands. We also see strong developments in dam safety programs, which is great. It's been an area that's very close to my heart, dam safety, and it has been for ICOLD for a long time. And we like to see countries like India and Malaysia and others developing national dam safety programs and codifying regulations to help dam safety and improve dam safety and protect precious lives around the world. As we work in these areas, we address the life expectancy issues of our structures. Many of our projects are 60, 70, 80 years old, sometimes more than 100 years old. These older structures require so much care and maintenance that we have to be part of that. And seminars like this today address that, the modifications and expansions, dam raises, reservoir expansions, and sometimes replacements of dams as the original dams no longer meet the design criteria. And of course, we're in a world of climate change. It's important that we address the changing hydrology, the shifting operations of the work that we are doing, how our projects change their operations to address climate change and the different hydrology that's around, and that's the science that's behind it. And that's part of our operation of existing projects, but also planning for our new projects. And there's a critical focus on the role of dams all around the world. We see that in the environmental considerations, the permitting and the regulations for dams. And ICOLD is part of that conversation. And the work that our technical committees do to understand the science and provide the world regulations, experience. These are important things, and that's the role of ICOLD that we're working on. And we are also addressing this capacity gap, this aging, where we talk about aging of infrastructure and dams, where there's also aging of our experts and our legacy experts, folks that have been working in dams and reservoirs and hydro for their whole life. Folks like me who've been around for a long time, trying to convey our knowledge through mentoring and training of our younger engineers. And that's where seminars like this come in. And I'm glad to see so much interest in this. And I applaud the Young Engineers Forum of ICOLD for being so active and sponsoring sessions like this. So thank you. I'll conclude by just reminding everyone we have our upcoming in-person ICOLD Congress in Marseille coming up in May, at the end of May and early June. This is going to be one of our best conferences. We already have almost 500 registrants, and we're hoping to nearly double that for an in-person conference in Marseille, the beautiful city of Marseille. This is our first in-person annual meeting since our 2019 meeting in Ottawa. And so I hope many of you who, if you haven't made a decision yet about coming to Marseille, be assured that we are fully committed to the in-person conference, to the personal health and safety of our registrants, and we're excited to be hosting this. And I'll be there with my family, and we're looking forward to a good conference. So thank you very much for the opportunity to make this welcoming speech. Again, thank you all very much for joining. Many of you have gotten up very early, and some of you are staying up late for this. And so thank you very much. And I look forward to a good day. Thank you very much. Bye-bye. Back to you, Lara.
Thank you, Mr. Michael Rogers, for your presentation. The group here is increasing. We are more than 60 participants now. Next, we'll have a message from SANCOLD IPF. Please, Miss Janice Zhang, the floor is yours.
Hi, Laura. Thank you very much. I'm just going to share my screen. So first of all, can you hear me? Am I on mute?
Yes, we can hear you.
We can hear you.
Sorry. Thank you so much. So, goeiedag, sunny bonani, and greetings from sunny South Africa. My name is Janice Zhang, and I'm the South African National Committee on Large Dams Young Persons Forum Chairperson for 2022. Before I begin my introduction on SANCOLD, I would like to thank ICOLD-YP and Valentina from SwissCOD for inviting us to our South African members to join in on this webinar. We really appreciate this forum for us to discuss and share knowledge. So thank you very much. And Eliott, we look forward to your webinar. So SANCOLD is the South African branch of ICOLD. We were established in 1965. South Africa is the country with the 8th highest number of large dams in the world. And as SANCOLD, we believe that it is imperative that the expertise our engineers have needs to be retained and passed on to the next generation of water professionals to ensure the ongoing safety of our aging dams in infrastructure and to maintain the assurance of future water supply. So as SANCOLD, our objective and mission is the creation and promotion of awareness and understanding among South Africans of the role of dams in the beneficial and sustainable development of the country's water resources. SANCOLD does this through advancing the knowledge and skills of design, construction, management, planning, operation, maintenance, and rehabilitation amongst our members. The SANCOLD-YPF was established in 2012. It was mainly established for our members under 35, allowing for a forum for us to interact and network with each other. Our objectives and mission is to transfer skills and knowledge from our older engineers to our young engineers to attempt to fill the age gap that we experience majorly in South Africa. We also want to knowledge share through our webinars, courses, and our online communication platforms, as well as create networking and career opportunities for our engineers and mentorship for professional registration and becoming approved professional persons. So the SANCOLD-YPF committee is democratically elected by our SANCOLD members. And for 2022, we have myself. I am a dams engineer based in South Africa. And then we have Dr. Louis Kutzer. He is a senior lecturer in the civil engineering department at the University of Pretoria. He has a keen interest in CFRD modeling. And we also have Dr. Janine Vonkerman. She is a water engineer specializing in sediment transport, river hydraulics, and hydraulic structures. And also at the end of this year, we will have a position open for our YPF committee. So if anyone is interested, please put your name forward. So for 2022, we are working on developing a 2-year outline plan of webinars and longer courses for our members, allowing for skill set development. And we are also indexing existing conference papers, allowing our members to have easy access to these as well. And then another thing is forming strong and long-lasting relationships with other professional committees, such as SwissCOD-YP, MozCOD, and the ICOLD-YP, this allowing for our young engineers to share experiences and knowledge and network with each other. We have a list of activities listed for 2022. I will not speak about them, but if you're interested in attending any of these, please feel free to contact us, and then we'll be able to engage with you and share our knowledge as well. Thank you.
Thank you, Janice. Thank you for your presentation. Now we are moving with the program, and I would like to invite Dr. Valentina Favero, coordinator of SwissCOD. The floor is yours, please.
Hi, everybody. Thank you. Can you hear me?
Yes, we can.
I hope so. Yes, great. Hello. So on the behalf of the Young Professional Group of the Swiss Committee on Dams, I would like to welcome everyone and thank you for your participation in today's event. It is an honor for us to have been involved in the organization of this webinar. So I will share my screen now. Here we go. Okay. So I would like to use these few minutes I have to briefly present the Young Professional Group of the Swiss Committee on Dams. Our group is relatively recent. It was founded in 2018. All members of the Swiss Committee on Dams up to the age of 35 are members of the Young Professional Group. The members come from different sectors. We have dam operators, engineering offices, federal offices, and research institutes. And the objective of our group are in line with the Young Engineers Forum of ICOLD, and we encourage the participation of young professionals. We offer the possibility to young professionals to share experiences. We try to promote the knowledge transfer between generations, and we organize activities for our young professionals. I put here a couple of pictures that were taken, I would say, at the very beginning of our activities, before the pandemic, of course. So in the first picture, you see we organize seminar meetings with senior engineers or experts in order to discuss technical subjects related to dams. Or we organize technical visits in construction sites. We also encourage the exchanges with young professional groups of other national committees. Last year, in May, we organized our first joint webinar with the young professional group of the Canadian Association of Dams, and it was very successful. And I also would like to say that we are always happy to collaborate and exchange with other young professional groups of other national committees. We always learn a lot from these experiences. In my next slide, I would like to promote the next event of the SwissCOD. The Symposium 2022 of SwissCOD will be held in Meiringen, right in the middle of Switzerland. I would like to present this event because it might be of interest for our neighboring countries, maybe. And the theme of the symposium are the new measurement technologies for dam monitoring. So I invite you to visit the website of our committee. You find it here below to have more information on that event. So I thank you very much for the attention, and I wish you a nice webinar.
Thank you, Dr. Valentina. Following this message, I would like to call Mr. Elias Baptista, Chair of ICOLD YEF, to present the general information on YEF.
Thank you, Lara. I will share my screen now. Thank you, President of ICOLD, Michael Rogers, to be here with us, and thank you all for accepting to participate in this webinar and make the presentations of what activities we are performing in our ICOLD national committees. I will start my presentation on general information of ICOLD YEF. I'm Elias Baptista from Mozambique, Commission on Dams. I'm the chairman of the ICOLD YEF. I'm also a geotechnical specialist in Valley, Mozambique. I will move here to the board of ICOLD YEF, myself as the chairman, president, and we have several members from different countries, from ICOLD national committees, France, Canada, Slovenia, Russia, Italy, and USA. The idea of ICOLD YEF was proposed for the first time during the annual meeting in Brasilia in 2019, and then young members from ICOLD submit the proposal to the board, and this proposal was approved in 2010, and we had our official meeting in 2011 in Lucerne, and right now we are 24 countries listed in this list here, and we encourage all other countries to adhere to these YEF committees. It's a good place to share ideas, share knowledge, and exchange experience between young professionals and more senior engineers. What is our mission and vision? This webinar is part of our mission, and we have as main objectives create network, as I mentioned before, provide opportunity to connect and share experience, and the core of ICOLD is to have members contributing to the national committees, and we encourage the participation of young professionals in the technical committees of ICOLD. We have here the target under 40 is a requirement. We meet once a year during the annual meetings, and we have virtual meetings, and we have our LinkedIn group that is a place to share and continue informing regarding what we are preparing. This is to say that we have been in several activities. We had the participation in ICOLD virtual meeting last year, and we have meetings with ICOLD board, and we had last year our first webinar, the future of rivers, with Valentina, with Maria Guel Pons from the World Bank. They shared their experience with us. It was a very successful event, and we hope that we will continue with these activities. The ICOLD YEF have several members from different countries, as I mentioned, and I am the chair, and we have here the terms of the board, and we will have 3 open positions for this year election. Every members of the national committees are able to apply for these positions, and we're willing that everyone can join us and be part of the ICOLD YEF. The 3 positions open, one is for the position of the chairman, and the other for normal members of the board. And for be elected, we have some requirements. Members younger than 40 years old and willing to contribute to YEF, and we encourage applications from every national committee members. And we have here the emails and LinkedIn group that we hope that we can share with us if you want to become member of our group. It's important to say that the candidate should be supported by the national committee that he represents. The typical term is 3 years, and we prefer geographic diversity and no more than 1 member per country. More information on YEF you can find on Marseille website. we have this link here. I share already on the chat. We'll have now Mr. Sara from French National Committee who will say some words regarding the annual meeting. Please, Sara, the floor is yours.
Thank you, Elias. Hi, everyone. I'm Sarah Delmas from Tractebel in France. I am here today to represent the Young Engineers French Committee and talk to you a few minutes about the ICOLD Congress organized in Marseille from May 27th to June 3rd of this year. The program of the Congress is online and was shared by Elias right now. But we wanted you to note that special events will be dedicated to young engineers. We also wanted to emphasize the importance to arrive earlier than usual in Marseille, if you can, of course, because short courses are scheduled as of Friday, May 27th, and the Young Engineer Forum is scheduled on Sunday, May 29th. Then, during the week of the Congress, you will have access to different activities dedicated to young engineers, such as a technical visit of Malpassé Dam site with very interesting experts. Note that registration is required for it. Then you will have access to a festive evening with various surprises, a mentoring program for 3 days, and many more surprises. So please come and join us in Marseille. And thank you for giving me the floor, and have a nice webinar.
Thank you, Elias. Thank you, Sara. We are in line with our schedule. Thank you. I would like to thank everyone for the participation. Now we are more than 70 in this webinar. We already shared the link for the ICOLD YEF group. So if you'd like, you can check here in the chat. There you will find more information about this webinar and other information on IEF. Following this, now we will have the presentation on decommissioning and replacement of arch gravity dam by a new adjacent double curvature arch dam. And I will invite Dr. Valentina to give a brief introduction to our speaker today.
Thank you. So I have the honor to present today's speaker, Eliott Odermatt. So Eliott holds a Bachelor in Civil Engineering and a Master of Science in Civil and Hydraulic Construction Engineering from ETH Zurich. Eliott has worked as a researcher in river morphology and sediment transport at the University of Lausanne. And in the last 3 years, he has worked as project engineer at the company Gruner Stucky, where he was involved in several projects, like the construction of a new arch dam in Switzerland, the static and dynamic verification of dams in project and existing dam in Switzerland and worldwide, the monitoring of the behavior and elaboration of safety reports for 5 large dams in Switzerland. He's a young engineer, active in the Swiss Committee on Dams. His topics of interest are dam safety, dam construction, sediment management, and environmental impact of dams. Today, his presentation will focus on the decommissioning and replacement of an arch gravity dam by a new adjacent double curvature arch dam. Eliott, the floor is yours.
So hi everybody, thanks a lot Valentina for the introductions. Thanks a lot to everybody for being here. I will share my screen and we can start with the presentation. I hope everybody hears me.
Yes.
Okay, so can you see my screen?
Yes.
Yeah.
Yes. Good, then let's get started. Just a few words about myself. As Valentina said, I work for a company called Gruner Stucky. We are an engineering company here in Switzerland. The company Stucky has almost 100 years in experience of building engineering of dams and mostly arch dams. And since 10 years now, we're part of the Gruner Group, which is the biggest Swiss engineering company. And since the beginning of this year, 2022, we operate under a single brand that is Gruner. And now I'd like to start with my presentation, if it's fine for everybody. So I would like to talk to you about the Spitallam 1 and Spitallam 2 dams, which are the dams we are talking about today. Spitallam 1 is an existing arched gravity dam that we are replacing with Spitallam 2, a double curvature arch dam. And after presenting you both dams, I would like to show you some an overview of the construction and the challenges of the site. Spitallam 1, existing arch gravity dam. So we are in Switzerland, in the middle of Europe, and we see Switzerland here is the typical landscape with the Swiss plateau, where we have all our big or more or less big cities and the dams located in the Alps. And the Spitallam Dam is here in the Bernese Alp. It's near Interlaken and the Jungfraujoch or Alech Glacier, some of you may know. And if we zoom in a little bit more, so Spitallam 1 is closing a reservoir called Grimselsee Lake, together with another dam. And we are located above 1,800 and 1,900 above sea level. And it's a reservoir volume of 100 million cubic meter. So out of the more or less 300 large dams in Switzerland, it's the 10th biggest reservoir. So it's a reservoir of importance for Swiss hydropower production. A few words about the owner and operator of this dam, because it's important to understand the project. So the owner, Favero, Kraftwerke Oberhäsli, has a scheme which is made of 8 dams, of which 7 are higher than 15 meters. It's 7 reservoirs, 13 powerhouses, 28 turbines, more or less 1.8 gigawatt installed capacity and 2,400 gigawatt hour yearly production. The highest point is 2,300 meters above sea level, and the lowest point is 620. So you see, it's a typical alpine hydropower. You can see from the difference of head. It's one of the big players in electricity production in Switzerland, thanks to their scheme. Now to the existing dam, Spitallam 1. So it's a arch gravity concrete dam. It was built between 1926 and 1932. It's founded on granite and granodiorite, so very good rock. It has a height of 114 meters from its lowest foundation point to the crest. It has a crest length of nearly 260 meters and a concrete volume of 340,000 cubic meters. At the time of the construction, it was the highest concrete dam in the world. If I remember well, it was then second when the Hoover Dam in the US was built. What is important to understand here, we have a dam that is made by 3 types of concrete. There is the mass concrete. I will show you my pointer here. So we have a mass concrete. Then we have an upstream concrete that has a higher cement content, and that was for better water tightness. And to allow the heat dissipation of this concrete with higher cement, a void was left here behind. So this void had to be filled later with a filling concrete. I brought you a nice picture from the construction time, and we see very well the biggest part of the dam with mass concrete. This upstream face concrete, and here we see the void that will then be filled with filling concrete. It's a very nice picture from nearly 100 years ago. We see they were bringing concrete with slides, and well, in the end, not a lot has changed, but a lot has changed. Okay, so the Spitallam one is nearly 100 years old, and it has aging problems. And here I'd like to focus on the measurement of displacement. We're measuring downstream, upstream displacement in the dam. And what we can see is that the displacement under the crest, so the main of the structure, is more or less stable. It's the green line here. The blue line, sorry, I read in German, it's the water level. And we see that since 2003, there is an increase in the upstream direction. But what the most important part is the displacement at the dam crest, so above this altitude. And we can see that it's clearly going upstream and more or less 1.8 millimeter per year. So these two different displacements create a dissociation in the structure and a crack here. Here, so it's interesting to see the pendulum that's measuring the displacement started to hit the edge of its the void, so it can't measure a bigger displacement than that. So because of the aging problems, the opening trend leads to an intolerable deterioration of safety, and the need for action was proven and was recognized by all the stakeholders. Then the question came out: should we repair or should we replace? So how I showed previously, the Grimsel reservoir that is close by Spitallam 1 is a key element of the a big hydropower scheme. And also we have a concrete that is 90 years old. So do we really want to repair such an old concrete? And because of these two reasons and some others, a decommissioning has been decided and a replacement as well. Now we will focus on Spitallam 2, so the replacement with a double curvature arch dam. So what are we doing now? We are building a new double curvature arch dam that is adjacent downstream of the existing dam. And what are the advantages? We have no interferences with the operation of the reservoir. As long as this dam is in operation and this one in construction, the reservoir can be operated. And also Spitallam 1, so the existing dam, is left in place and is then bypassed by a water level equilibrium gallery. That means we don't need to demolish, we don't need to transport the material, and we don't need to store the demolition material. So we can spare a lot of money by operating the reservoir and by leaving the dam in place. And also, this new dam, gives us the possibility to heighten the dam at a later stage. That is a wish from the owner that has a project that is under discussion. And so the dam is designed to be heightenable of 22 meters. I'd like to show a ground plan of the project. So we see really well this existing dam here, arch gravity, and the new dam in red, double curvature arch dam. We also some galleries that will be built. Here of most interest is this one. It's the equilibrium gallery to assure that the water level in the big lake and in the small lake, let's say, are always the same. So some facts about the geometry. So the geometry of the new dam is it's an arch dam with parabolas with an height of 113 meters that can heighten of 23 meters. The crest length is about 209 meters with a width of 8 meters and 4 for the heightened dam. The thickness is about 20 meters at the base, and the concrete volume is 210,000 cubic meters. we see the difference with the existing dam, which was 340,000. We can spare 40% of the concrete thanks to this arch dam, and the thickness at the base is also very self-speaking about the advantages. So why an arch dam? We are in a narrow valley, so it's perfectly suitable. And as I said previously, we choose the parabolas, a parabola arch dam, and here you can see the center of the circle and the equation. We can recognize the typical quadratic equation of the parabolas, the quadratic term, the linear term, and the constant term. And these are the equation defining the geometry of the dam. Here also in plan view, we can see the two in blue, the two main parabolas, upstream and downstream. And also we have the red parabolas here are the abutment parabolas, where we need more thickness because of the higher stresses. So that's about the dam and the geometry. Now I'd like to give you an overview of the construction, the execution, and the challenges. So the schedule, the rock excavation started in 2019. It was 2 years of rock excavation. Then we have 4 years of concrete pouring from last year, this year, and the next 2 years. From next year, we will also start a joint and rock grouting. And the last year, 25, will be impounding. So the site for the execution, here I take you an outcut of the Swiss maps. You can see we are on an alpine pass road that is nearly 2,000 meters above sea level. So you can imagine the logistic challenge to bring everything up there, the cement for concrete and the people and all material. And also we are very high in the Swiss Alps, so you can imagine the weather in summer is not always perfect. That's a picture I took in 20th of August. So it's summer in Switzerland, but up there it was totally cloudy. And also we have a very long winter at this altitude. That's about mid-October to mid-April. Here a few pictures so you can imagine. We see we are in a zone of danger of avalanches. The picture is of 18th of November, and it was already snowy. This one is the 29th of November. So you can see it's a pretty big challenge to build at such altitude in Switzerland, because we have very short construction seasons. And that's also the reason why we need 7 years to build this dam, because it's actually 7 seasons that are only a few months long. Okay, so now let's jump in the rock excavation. We have a near vertical foundation. The granite work is we have a granite rock mass, and we're going very close to the existing dam. About the procedure, we started with a pilot cut. We have on one side, we are using the crest of the existing dam here to access this pilot cut, and the other side they have to build a tunnel. And if we zoom in a little bit, that's what it looks like. So this is the pilot cut. And then after the pilot cut, they started to descend with kind of rock platforms. And if we go a bit, so here it's the September of the first year, then it's November. Here, the beginning of the following year. And I want you to note how close we are to the existing dam. So this picture can be a bit frightening, but of course we did a very accurate calculation of stability of this dam and the dam abutment. And our federal authorities, of course, were implied. They checked all the calculation, and so everything is safe. And but you see, it's pretty challenging how close we are. If we go, okay, let's go. Now we are in June, and yeah, still June. We see we are descending. In July, almost done. And we see we have some galleries also going in the rock. You can observe the rock mass. And here's the complete for both abutments. So this is the right abutment and this is the left abutment seen from downstream. And also that's the lowest part of the excavation we call the swimming pool that is below the existing terrain. So this rock near vertical wall need a complicated access. They did with steel stairs, and but you see it's pretty challenging. Okay, after excavation, we had the concrete pouring. We did the first lift on the 22nd of June last year. That's what it looked like. So the concrete pouring we're doing it traditional, let's say. So we have one machine to move the concrete, and then we have one to vibrate the concrete. We're mostly using two types of concrete: mass concrete, which in Eurocode names is C2025, and we have aggregates from 0 to 120 millimeters. And then we have a facing concrete, which is a better concrete, a C2530, and it also has a smaller aggregate, 0 to 63 millimeters. So we had the first season of concrete. That's already in August. We see we are already rising with the leaders blocks. And the follower block are there in between. Here they started a leader block halfway, and that's a month later. So we see we are rising. We see some galleries here in the follower blocks. Here we have the whole of bottom outlets, and here there's a picture of the cranes on the existing dam. I just mostly wanted to show that it can also be sunny up there in August, not only cloudy. And at the end of the season 21, we need to get ready for winter. And so we put some isolating mats on the lifts, and we closed the galleries. And also the contractor did a filling with soil on the downstream of the dam. We see they just let the trench for the bottom outlets. And we see very well these leaders and follower block, a typical skyline, let's say, of a dam construction. And that's a view from downstream with all these mattress isolating mats, and a webcam. This is a bit of poor quality, but it's nice to see also from the upstream the dam being ready for winter. So another aspect I wanted to share with you was the post-cooling of concrete. So what we did as engineering, we did a thermal analysis with finite element method, and you can see here, for example, an outcut of the temperature in concrete using only natural cooling and with post-cooling. So you can see we can go up to 35 degrees, and that's why we decided to use post-cooling coils. So the post-cooling coils, that's more or less what they look before being embedded in the concrete. And what we are feeding all the coils with a conveyor pipe. This huge pipe here, it's feeding cold water. And then we have the return pipes. All the coils have return pipes that go to a gallery. So yes, everything is connected to galleries thanks to lateral niches. And here's what it may look like. So we have these big feeding pipes and all the coils coming back in the galleries. So we can regulate every single lift thanks to the single coils coming back. Another interesting aspect in my understanding is the joint grouting. So as I said, we are building an arch dam, but with leader and follower blocks. That means we have joints in between, and we need to grout these joints to add an arch effect. This is an execution drawing for joints. We see we have an entire piping system Also nice details here are the shear keys, and they're only in the upper part of the dam. And this joint quadring system embedded in concrete looks like that. So we have a groove that is to pump in the grout mix, and on the opposite side of the panel we have a vent which is built exactly the same way, and this allows to let the air out of the joint and fill it with the grout mix. Another key element of this grouting panel is the water stop, and here we see a water stop that's built in a leader block. And when we take out the formwork after the pouring, it looks like that. We just need to unfold, and we can have it through the leader and the follow blocks. I wanted to show this picture because you see it's a really complicated data to execute, although it may look very simple on paper. And also the entire grouting system is connected to the galleries. So if we take our picture from before, we have here our cooling system, and here we've got all the pipes for the joint grouting. We also saw these water stop bands around the galleries, the groove, and the pipes. So with that, I'm coming to the conclusion of my presentation. So the Spitallam Dam is in execution since 2019, and impounding will be in 2025, hopefully. For me, as a young engineer, it is a unique opportunity. I don't think there are a lot of arch dams under construction in Europe. Maybe it's the only one. For Switzerland, it's clearly the only one. We have many challenges with these construction sites. As you have seen with the details, building a dam is not only pouring concrete. We have a lot of details, a lot of embedded systems. And yes, it was a big challenge, and I'm really happy to work on this project. I'm available for any question. Maybe you can get my contact through the Young Engineer Forum or the SwissCOD Young Group. I wanted to leave you with the most recent picture I have of the project. Oops, sorry. That is a picture of a month ago, I think. And you see the state of the dam right now. It's covered with snow. So the next steps in the construction, we start cleaning snow very soon, I think in a few days, if it's avalanche safe, because it's still winter in Switzerland. We also have snow coming in the next days, so maybe they will be delayed. They will need to clean first the access roads, and then they can clean the site from snow, and finally the dam, and they can start to build again. So I'd like to thank you all for being here, for listening to me. Also, I'd like to thank all the panelists or everyone that presented. Michael Rogers for also opening, and Lara for leading this webinar. Thanks a lot. And do you have any question?
Thank you, Eliott. Now we will go to the questions. I would like to say that you can share your questions in the chat, and later we will have the answers to all the questions in the IEF LinkedIn. I would like to ask the organizers and presenters to turn on their cameras, and we'll give the priority for them to make the questions. And then we'll jump to the remaining questions that all the participants have for Eliott.
Yes, maybe I see there are some question in the chat. I may take them in order if it's fine for you.
Yes.
So tell me.
I would like to start with Michael Rogers. Would you like to present your question, to voice your question, or?
Sure. Eliott, very nice presentation. Thank you very much. Wonderful, wonderful project. Congratulations. So the question I had is your picture on the left abutment excavation. The excavation itself seemed very deep. And so my question was, is that because of the rock geology that was driving you there, or were you trying to maintain the geometry of the new dam, or was there some other reason why there was such a deep excavation, which looked to be quite a bit of competent rock had been taken out?
Well, actually, it may be an impression of the picture because the excavation is not that deep. It's less than 10 meters deep, and we have very good rock. So of course, there are some geometrical questions. We were a bit blocked between the existing dam and also on the dam stream. The operator has several galleries and caverns, so we were a bit blocked between the two, and we needed to design the arch correctly. But the geology is pretty good, and I don't think the excavation is that deep. It may be an impression of the picture, actually.
Okay. Did you have to lower the reservoir to lower the forces on the existing dam during construction?
No, I see also another question about that. We had no restriction of operation, but we had a reinforced monitoring of the existing dam and of course of the excavation itself. But this was one of the reasons this solution was chosen, because there was no restriction of operation. So for the operator, it means a lot.
Okay, thank you very much. I have no more questions, Lara.
Thank you. Next question. I see that some participants already wrote their questions in the chat. I would like to know if someone would like to present their question, voice their question. If you'd like to please raise your hand. Otherwise, I'll read the messages the questions here from the chat.
I have a question for Eliott. Thank you for the excellent presentation, and
thanks.
And for sure is a very challenging project. And we know that the weather is challenging, but what we have regarding the technical aspects, any that you have faced and want to share with us?
It's hard for me. We at SwissCOD-YP are not doing the local site management. We're in close contact with the management, but there are many challenges, many questions about what could be prefabricated, what needs to be done in place. For example, I saw a question about the galleries. They are not permanent formwork, so they are formwork, and then we take the formwork away. And it was really a choice, for example, of the owner, because we as engineers and them as operator, they think it's important to see the concrete of the dam. So we did not want it like prefabricated or precast galleries. And but yeah, many challenges, and I cannot pick one.
Thank you.
Thank you.
Lara, can you read the questions on the chat?
Yes.
Yeah.
Yes, I will do that. So we have the first question here from Odermatt. I hope I'm pronouncing your name correctly. The question is, did you have special or extra movement monitoring of the existing dam during the excavation and construction? And did you have operating rules for the dams during the construction period?
So, as I said previously to Mr. Rogers, we had an extra monitoring system. Of course, the dam has its own system that is already really good and complete, but we had an extra monitoring for the existing dam and of the excavation itself. And this solution was chosen also because the operator did not have to operate its dam differently. So the existing dam is safe, it's stable for a few years now. It was a long like a long-term or term choice to replace it, but we did not need to have special operating rules during the construction.
Thank you. Second question here from Emmanuel Rob. Considering the excavation of the new arch near the old dam, what are the criteria to say if it was acceptable?
Yes, long story short, we did very raffinate calculation about this the existing dam, and it was of course one of the big questions of the project. And what mostly the 3D calculation told us is that the main stresses, the main forces go behind the excavation. So that's why we can say it's acceptable. I hope it's enough as an answer.
Okay, thank you. Felipe Vicente Lázaro. Okay, he's complementing your presentation.
Thanks.
Catalin Popescu. How would the two dams function together? Will the old one be completely decommissioned or up to a certain level? Will it need a reservoir emptying? I actually can complement this question with what are the challenges that you will find having these two dams structurally, environmentally, related to flood operational control?
So it's a good question. Actually, the idea is that the existing dam will have a bypass, so it will be like an obstacle in the middle of the reservoir, but it will not be operating or in operation because it will always have the same water level on both sides of the dam. So that's why we consider it decommissioned. And so how they will function together, they have the same crest level, they have the same let's say the bypass will be the same level of the bottom outlet, so that the entire dam lake can be emptied with the bottom outlet. So the old dam is not functioning anymore. It's there, but it's like transparent. And about the environmental impact, it's a special project because we are not building a new reservoir. We're building a new dam, but it has mostly no impact because a dam is already there, and we will not change anything to the operation. So of course there was an environmental impact assessment. I was not personally involved, and so I could not say any details, but the impact itself is very low. It's exactly the impact is the one of the existing dam actually.
Okay, thank you. Again, if anyone would like to make their own question, you can raise your hand and we will open the microphone so that you could make your own question. I will follow the next question in the chat from Luis Cotis. Well done, Eliott. Thank you for explaining Can you explain the construction method used for the galleries? Are the galleries constructed with permanent formwork?
So here I can share my screen again, and just if I go back to the gallery pictures, or maybe this one was a good one actually. So here they're done with regular formwork. Let's say the tunnel part or the gallery part as a they are done pieces, and they add some local formwork when needed. And when the concrete is poured after a few, I think 2 weeks maybe, they take the formwork away and use the same formwork for other places for the next gallery. So it's not permanent. It's really decast. I don't know if we say like that in English. And as I said, it was a wish of the operator to see the concrete of the dam. also a philosophy here in Switzerland that we do this monitoring at a very high level, and we want to see the concrete evolving. We want to see the cracks, if they are changing, if they're closing, if they're opening, and for that you need to be in direct contact with the dam concrete, and that's why we have this this traditional formwork that is not permanent. I hope it's clear.
For the next question, Eliott would like to make his own question. So please, the floor is yours.
Good afternoon, Eliott. First of all, congratulations on a really good presentation. Very interesting project and very clear and concise description of what the work you've been doing. I'm speaking from Oregon in USA. It's 5 o'clock in the morning when the presentation started, and I'm really glad that I got up early to join this presentation. So my question regards the alignment of the dam. Looking at the images in one of your presentation slides, the left abutment is very close to the left abutment of the existing dam, whereas the right abutment is further downstream. Were there any geological or foundation issues which resulted in the right abutment being moved further downstream?
Thanks a lot for the question. I will share my screen again. We can, my presentation again. So maybe just show the plan view of the dam. Let's go back. So the geology, I have to say, is an excellent geology. Up there, we are founded in granite, but we have some faults, but they are really closed faults, really small faults. So the reason was not geological; it was mostly here we are. I'm going up. Sorry, it's mostly geometrical. As I said, we are blocked, let's say, geometrically. Here's the existing dam, so of course we don't want to go too much upstream. And here you may see, sorry, laser pointer. Here what you see here is an existing cavern or gallery, a rock gallery, and we can't go too much downstream because of these existing structures, because they cannot be flooded. So we had a very restrained space, and we could try to rotate a bit, but because of the form of the valley, that's why we decided to put the dam here and there. Of course, it's very close, and the picture, they look like it's very close, but as answered previously, this circle here unloads its forces here, mostly according to the 3D calculation. And that's why it's close, but it's not a problem actually. But for your question, it was not a geological reason. It was really geometrical, because the geology is excellent. We really can't complain about the geology. And it was mostly the geometrical challenge of putting everything together.
Great, thank you very much.
Thank you for your question.
Just to mention that we have 5 more minutes for your questions, and the remaining questions will be available on the LinkedIn page of IEF. Next question is from Felipe Vicente Lázaro. Some insight on environmental impact assessment and any specific or particular requirements. Maybe he's questioning about the environmental license for this new dam.
Yeah, I must say the truth. I'm not really aware of this aspect. We were mostly involved for the structural design and the calculation. As I answered your question before, Lara, I think the impact is pretty low in the sense that the damage was already done with the existing dam. But I'm sure we have a law in Switzerland that asks us to evaluate the impact of every big project. I'm sure there was some evaluation according to Swiss law.
Philip Lazar raised a hand. Can you please can go?
Yes, thank you. I just want to complete the question. I understand that there is no limited permanent impact, but sure, during construction, the fact you have to transport all the materials, you have to stockpile this material on site. Probably you have some specific requirement. We know that it's not easy to build a dam in Switzerland at this altitude. Thank you, and best regards from Washington.
Hi. So yes, about the impacts. Of course, there are impacts. I must say that the aggregates come mostly from site, so from all the construction of galleries, from previous projects as well. But of course, cement has to be transported from Swiss Plateau, so it's 3-hour road with trucks. And but during the construction itself, I know there are a lot of mitigation measures, and also quality water monitoring. And I can say I don't have details, but I know the laws in Switzerland are of course respected, and they're pretty strict about such construction.
Okay, thank you for your answer. We have the next question from Zunaida Ref. Will the old dam still be monitored? The decision to build a new dam was related to the life of the old dam?
Yes, absolutely. Thanks for the good question. That's of course it will be monitored as long as possible. So nowadays it's monitored with pendulums and many other instruments. These of course will not be accessible because the dam will be flooded. But it's foreseen to install some reflectors on the downstream face of this dam, so that we can do some geodetical monitoring. And this, let's say, as long as possible. Of course, with time, the concrete will most likely deteriorate, but it's foreseen to monitor the dam. Thanks.
Thank you. A question from Mr. Michael Rogers. Can you share the estimated construction cost of the new dam?
I think it's about 100 million Swiss francs, so more or less 100 million US dollars. But I'm not sure. I think it's about that.
As a follow-up question to that, as a young engineer working on a project like this, did you have a good relationship with senior mentors or others at your organization to help guide you through this type of a very large project?
Yes, absolutely, absolutely. I'm really happy here that at Gruner Stucky we have this structure with senior experts and let's say the whole range between the senior and the junior engineer, and everybody is really helpful. And I of course I'm not alone on the project. I'm really the junior engineer, doing a lot, ranging from that to that. But I had all the support I needed, and it was really really an awesome experience to be surrounded with people with experience and having the chance to learn from them.
Well, I hope we get to see some technical papers at future ICOLD meetings. I know the ICOLD Concrete Dams Committee is writing a new bulletin on arch dam design, and I hope that you will find some interest. It's being led by SANCOLD, Dr. Quentin Shaw, and I think it will be a very good bulletin for arch dam design. And I think this could make a good contribution. So thank you again, Eliott.
By the way, I'll make some advertisement. There will be a paper for Marseille that will be coming out about this project.
Wonderful. I hope to see you there.
Lara, your microphone is muted.
Sorry, thank you, Elias. Our time is we've finished with our time for the questions, but I would like to finish with the question from Zunaida Ref. Elias, could you open his microphone so that he makes his question to finish the previous question that I already.
Yes, I already open.
Thank
you, Lara. Yeah, it was just on the old facility that will still be monitored. It's just, I'm sure that with it being flooded, you would have to do some sort of modeling to assess the impact of that old dam on your new facility, whether there is any. But I think there is another person further up that spoke about a sediment management plan and the integration between those two dams. If you could just comment, and other than that, just a comment that well done. Thank you. This was a great presentation.
Thank you. Yes, for sediment management, I must say the owner is pretty capable of its own. So they do their own sediment management without consulting us as a company, engineering company. And for the impact between the two dams, of course, we assessed the impact of the two dams, and because of the movement, if something happened, it should be upstream in the bigger reservoir. But the impact was assessed, and it's pretty low. We don't really fear the impact of the old dam on the new dam.
I think to complement the sediment management plan question, there is a question here from the Hal Sudesh. How will it be integrated, the management plan for the two dams? Is there any integrated plan already for the management of the sediment?
Unfortunately, I don't know really. I am sure the owner is really capable. I'm sure they're doing something for sediment management, but I'm not aware of anything or informed, let's say. Sorry.
Thank you. I think we don't have more time for questions. If any participant still has questions, you can write in the chat, and we will, as I said, provide the answers in the IEF LinkedIn. Now, to close our session, I would like to call Ms. Professor Robert Bos, President of the SwissCOD. But before that, Elias, if you want to add something, please.
No, we can proceed.
Okay, so we'll proceed with Professor Robert Bos' presentation, closing remarks. Please, the floor is yours.
So, first of all, thank you very much for inviting me to make some closing remarks. I'm a current president of the Swiss Committee on Dams, and on their behalf, I would like to warmly appreciate also what you have done in organizing and conducting this very nice webinar. If we go to slide 2, I would like to, first of all, quickly talk about the role of dams, levees, and reservoirs. And we see here the well-known Sustainable Development Goals of the United Nations. And if you press again, I hope you see then the three main, I would call it main roles dams have: to alleviate poverty, to provide water for irrigation and drinking water needs, and also to supply water for producing hydroelectric energy and have clean energy. Additionally, if you press again, I would say dams play a vital role in also having irrigation and agricultural needs and supplying enough food for the increasing world population, so zero hunger, number 2. And of course, in times of climate change and adaptation needs, with increasing frequency of droughts and floods, we need also reservoirs to combat climate change issues. If we go on to the next slide, please, then I would like to share a few thoughts on where I see the challenges in dam engineering. And first of all, I hope this works technically. You should see 3 photos in the upper half.
Yes.
In the center, we have a a new dam planned in Switzerland for energy, again, supply of electricity. So dams play a vital role also for the energy transition in a number of countries worldwide. On the left, we still have also an issue and some contrasting interest when it comes to waters protection. There is more severe legislation worldwide, and there is certainly also a need to have dams as sustainable as possible, not to be too restrictive in terms of free migration of fish and so on. On the right, aging structures in many countries who developed their dam infrastructure early, often after the Second World War, there is an increasing need to rehabilitate and upgrade existing structures, not to have dangerous situations as we see here. And the project that was presented by Eliott Odermatt is a very good example how to replace an existing dam who does not no longer fulfill its role by a new structure. Then if you press again, please, you should see number of more photos. On the left, sediment management is a big issue. We heard about this also today, because our reservoirs fill up with sediments, and this is very closely related to waters protection. If we want to have nature-like rivers, we also need the sediments in the rivers. So we should pass, wherever possible, sediments to the downstream reaches of the rivers and not to trap them behind the dams. This is a win-win for ecology and for dam operators. Climate change adaptation. Dams, and especially reservoirs, so impounded by dams, they help to greatly really dampen the floods and to provide water in times of scarcity and droughts. And this becomes more and more relevant, as we have seen recently. Again, let's just think of last year's large floods in Central Europe, in India, in China. This is a vital role again. And last but not least, safety and resilience. Also in the mountainous and alpine areas where we have a lot of our reservoirs and dams, there is an increasing threat of natural dangers and hazards due to instabilities with permafrost thawing and so on. So I think this is a real vast field of challenges for dam engineers, and the young engineers who are particularly taking part in this webinar have a great amount of work and very interesting work ahead of them. And let's go to the next slide, please. So speaking of young engineers, I think to educate and train them is a vital role of the Young Engineers Forum. And one measure to do this is to attend the congresses of ICOLD. We heard about Marseille, and I would like to promote another congress that is supposed to take place next year in September. In Switzerland, we are proud to host the 12th ICOLD European Club Symposium. And this is in line with our 75th anniversary of the Swiss Committee on Dams, which will take place in 2023. And we decided to have the topic of the role of dams and reservoirs for a successful energy transition, because this is an important topic also in Switzerland, but in a number of European countries where hydroelectricity is the central part of the energy system. And by the way, we will offer a one-day field trip to the Spitallam Dam that was today's center of focus of Eliott Odermatt's presentation. So you will have the chance to see the site under construction and to learn more about this. I heartily invite you to attend this European Club Symposium next year in Switzerland. And last but not least, if we go to the last slide, I would again like to express my warm thanks to all persons involved in organizing today's webinar, which I personally found very interesting, and in conducting this webinar. And of course, a warm thanks to Eliott Odermatt for sharing his very interesting insights and results of his studies and his experience he gained during construction. and another dam that is planned in the same region is seen on this photo on the left side. This is an animation. This does not exist yet, but this is another important reservoir for the Swiss energy transition. And with this, I would like to close. Again, thank you to all involved from ICOLD and the local national committees. Thanks for your attention.
Thank you all for being here.
Yes, thank you, Professor Robert Bos, for your closing remarks. Thank you, Eliott, for your presentation. And thank everyone for participating and for the questions. Again, for more information, just follow the links shared by the organizers in the chat. And I think our webinar is finished.
Thank you all.
Thank you very much
Bye.
to everybody.
Next time.
Thank
Bye.
you.
Thank you. Good job, Laura.
Bye
Good
bye.
job,
Thank
Elias.
you very much.
Thanks a lot to everyone.
Thank you.
Thank you.
Sorry.